Hey everybody, welcome back. This is now the second segment of this discussion about cables. And, rebar. Rebar. Man, I was downloading the last video clip on the computer and I thought, rebar, that's what I was trying to think of in my senior moment a minute ago. You know, it's funny, you get in front of the camera, and that happens. You can't even remember what it was you were going to say. And I don't practice any of this stuff, guys. I just roll with it. I just have something in my head. I want to talk to you about it, and I just start talking. So sometimes it doesn't come out in the greatest of orders, but hopefully I'll get it all out there. Hopefully this time I won't forget what it is I was trying to think of. So let's start with the video that I did months ago, and let's talk about that and what the purpose was of that video. So what I did was I took an old receiver and it had an old connection on the back that you could hook up an antenna to for AM or FM reception. And back then, back in the day when we used tuners and receivers, there'd be a connection on the back that would hook up what's called a T-type antenna, which would just be two wires run side by side, and it would go up the wall and then split into a T, and that worked really well as an antenna. And the purpose of the whole thing was to illustrate that your cables, especially your speaker cables and every cable in your system, can be or is either a good antenna, meaning that it's picking up everything. It's picking up RF noise, which is radio frequency interference. It's picking up electromagnetic interference, which could be generated from your power supplies, from your gear, or lighting in your room, and all kinds of things. Or it could be a filter, and it can be rejecting those things. So in order to illustrate that whole situation, I hooked up different types of speaker cable to the FM receptacles there. And of course, a side-by-side zip cord regular speaker cable was a great antenna. And the signal strength on the meter, just because it went this way for you, it shot right up. Good signal strength. And some of the ones that were twisted would go up a little bit. It was still, there was some filtering going on in there because of the twisting. And then we hooked up one of these that was a multiple strand braided cable where the conductors are all crisscrossing over on each other. And it wasn't a good antenna at all. So it's the type of cable that we consider to be a filter. And so the Flat Earth guys came out of the woodworks and tried to prove that what I was doing was invalid and you're not showing anything other than whether or not a speaker cable can be used as an antenna or not. It has nothing to do with audio, and all that stuff that's in the air, it doesn't affect the audio signal, and all kinds of crazy stuff. And I forget, we don't hear RF noise. That's too high. That's in the mega frequency ranges or the gigahertz ranges, and we only hear to 20,000 hertz, so we don't hear that stuff at all. That's a crazy experiment. That makes no sense. You're stupid. You're an idiot. Boy, did they come out of the woodwork. And even some of the guys that I know thought, man, they really just pasted you over there. But as I read through, I realized they don't know what they're talking about. And somebody says, that's crazy. You're trying to sell snake oil. And actually, I wasn't trying to sell anything at all. I'm trying to educate everybody. And there was a lot of these guys that are what we call electrical engineers or have their EE degrees, and they wanted to come on there and say that this stuff has no effect, and that the electromagnetic interference or the radio frequency interference is not interference at all. It has no effect on the audio signal. Well, guys, I hate to burst your bubble, but for years and years, there's been an entire industry within the audio industry just dedicated to removing the noise from your lines, and in all places, from the power supply all the way to your speakers, and including, as I said, your speaker cable, which means there are companies dedicated towards removing radio frequency interference and electromagnetic interference from the speaker cables because it has an effect on how the audio system then sounds. And with that, little presentation I made, I added a link up above there where you could go and see a little segment on how certain amplifiers work, especially tube amps. A lot of tube amps have, well, in fact, almost all tube amps, very few don't, have what's called negative feedback, which means they're resampling the output and looping it back through the input. And so anything that's being picked up on the speaker cables can get re-amplified by the amplifier. There's also amplifiers out there that are unstable, that need to see a certain amount of capacitance or resistance or a certain amount of inductance in order to maintain stability. So what's going on the speaker cables can be very important, and canceling out that noise is significant. Like I said, there's an entire industry out there dedicated towards that, and I'm going to point you guys straight to some of the best ones out there. So I'm going to have to get out my reading glasses here. And the first cable company, I want to tell you about cable companies that specifically address these issues. And I want you guys to go to their websites and read their information and learn. These are not companies that are trying to sell you snake oil. Trust me, there's an entire industry out there that have researched and developed this stuff and have made huge strides in it. The first one, Transparent Cables. And Transparent Cables has some fantastic cables, and they have passive filtering systems. They have blocks. They have a big block on the cable that is full of basically a filter to remove a lot of that RF noise from the signal path. And from their website, it talks about noise antennas. It's referring to your speaker cables as noise antennas. If not properly designed, the cables, power cords, and power distribution in your system can act like conduits for noise that interfere with your system's ability to reveal music fully. Typical wire acts like an antenna, and I didn't make this stuff up, guys. This is known in the industry. This is well known in the industry. Typical wire acts like an antenna and is capable of transferring frequencies into the gigahertz range and beyond. For the best audio and power signal transmission, this ultra-high frequency bandwidth is unnecessary and actually introduces noise. Unwanted noise can interfere with delicate, high-speed digital signals. And yes, digital signals. I love the guys that are going to say, digital signals, there's nothing on there but X's and O's. No, it's not X's and O's. Ones and zeros. Hugs and kisses. That's what's on that line. Ones and zeros. That's the only thing on there. No, that's not the only thing on there. And that digital transmission is very delicate, and it can be disrupted very easily. And there's a huge difference in those cables as well as other cables. I'm not going to go straight into digital. I can't wait though. I'm going to do some segments on digital. But for right now, I'm trying to help you guys understand there's a whole industry out there dedicated to removing this noise from the line. Next one I want to tell you about, MIT cables. MIT cables also uses passive and active filters on the power cables, on the speaker cables, on the interconnect to remove noise from the system. They even have some that allow you to control the inductance and the capacitance of the cable, making adjustments to it, to impedance balance the whole system back to your amplifier and all kinds of crazy stuff. And yes, it makes a noticeable difference in the way it sounds. Yes, I've heard it. I've heard transparent cable demonstrations. I've heard MIT cable demonstrations. I've had some of them. I've compared them. Absolutely, that stuff makes a difference. Now here's another one, a few excerpts from MIT cables. Passive and active filters that are adjusting the capacitance and inductance. I just mentioned that. This is funny to me. This is what they get asked a lot. This is under their frequently asked questions. Can an average person hear the difference? They said, you bet, with an exclamation point. One of our favorite demonstrations is to use lamp cord as speaker cables and then add the AVTSCI modules to each channel and play the difference. In 4 days during the Rocky Mountain Audio Fest, we thrilled audiences more than 30 times a day. There were none present that claimed to not hear the dramatic improvement in articulation, detail, and genuine sense of being there. Absolutely. I've heard some of these demonstrations. I've been a part of some of these. I've conducted some of my own demonstrations where we're not only demonstrating, but sometimes we're testing this stuff and we're comparing one cable to another. Absolutely, it makes a difference. The next one I want to tell you about, Shinyata Research. The Art of Noise Reduction. Now, I've met these guys. I've met Kalen, and probably one of the sharpest guys in the industry. I can't brag on that company enough. Guys, you have to go to Shinyata Research's website, and I want you to look at the information that's there on the website, and look at the testimonials, look at the, there's a link there that'll take you to videos, and there's a whole slew of videos that he's done. And a lot of these videos, he's gone in and actually shown measurable differences between the cables and explained what it's doing and how it affects the audio signal. And it's very thorough. The guy's brilliant. All you flat earthers out there that want proof, you want to see measurable difference, go to Shinyata Research's website and take a look at what's on there. It's irrefutable. The next one, I want to read you a whole little quote here from Ray Kimber at Kimber Cable. That's another company that has really dedicated their whole company towards removing noise. They have some cables that's very much like what you see here that are braided and counter-rotating braids, and when you crisscross those conductors on there, it will cancel out a lot of the noise. And Ray Kimber talks about this and how he discovered that and how he's basically built a business around this. This is very interesting. I'll try to read through it pretty quickly here. It starts in the beginning. It's called The Legacy in the Making. It's there on their website if you want to take a look at it. In the mid-70s, Ray Kimber worked at a sound and lighting company in Los Angeles. The first big can't even pronounce anything, were being installed at the time. Traditionally, sound and lighting systems were not installed right next to each other, nor did lighting systems ever have such an array of noise-generating fixtures, such as strobes and other flashing and dimmable lights. But in a discloth queue, I can't even say it, the lights and speakers are installed next to each other. The speaker cable was acting as an antenna array and bringing noise from the lights into the sound system. Imagine that. The speaker cables were picking up noise. Can you believe that? In an attempt to solve the problem, they encased the speaker cable in steel conduit. This did help with the noise, but it also had unintended results of lowering the fidelity of the audio. This happened because the steel conduit interacted with the magnetic field of the speaker cable, and that's absolutely true. A lot of these guys say, "Well, I'll just shield the cable. I'll use shielded cable." Shielded cable can be detrimental to how it sounds. It will suck the life right out of the signal a lot of times by using a bunch of shielded cables. And the shielded cable is only rejecting the additional RF noise that it's picking up as an antenna. It's not doing anything about the noise that's already on the line. And in a lot of cases, a lot of that noise is already on the line. Remember, this isn't shielding, this is filtering. So keep that in mind. Then Ray had the idea of some counter-rotating sets of conductors to cancel out the magnetic interaction effect, but then also surmised that the counter-rotating sets of conductors would not likely pick up noise even without the conduit. He was correct. That means it wasn't necessary that it needed to be shielded as well. Just the fact that it was braided in a counter-rotating braid rejected the noise. And noise was greatly reduced. Ray was quite surprised at the difference in the perceived audio quality. It made a difference in how it sounded. Oh my goodness. And what was discovered was the noise eliminated and improved fidelity that set him on the path to develop cable designs. And there's more there. I'll let you guys go to the website and read it. Like I said, guys, there is an entire industry out there dedicated to removing the noise from the lines. And all you guys out there who said, RF noise won't matter, that you can't even hear that. Guys, again, there's a whole industry out there making cables that have filtering systems on there or that use braided geometries to remove that, and it definitely makes a difference in what we hear. All right, that's all I wanted to say on that stuff. Next segments that we're going to do still, we're going to look at we're going to look at some measurements. I'm going to look at a measurement that's going to show you guys, well, really, it's going to illustrate what I'm trying to tell you right now. It's going to illustrate this very well. Hopefully you'll get it and think, well, that makes sense. I'm not trying to go head to head with the guys that want to draw out all the math and calculate everything and try and measure every little thing to say, okay, then here's what this means, and then draw a conclusion based on a belief. Not about the beliefs. So that's for these guys, the flat earth guys. Oh, not flat, that's me, not flat. The flat earth guys are the ones that really don't want to do the science. They don't want to do the final test. Listening. We're all about listening. I'm all about making your system sound better and helping you get there. And one of the ways is you have to open up your mind to this stuff and try it for yourself. So next is some measuring stuff. It'll be a short segment. It'll be fun. Thanks for joining in, and hit the subscribe button and join our little subscription base. That's all for this segment, but we'll be back with another one, so hang on.